Assalamu alaikum. I am Rifat Abdullah. My student ID is 1913527330. I am from Software Engineering Department from Daffodil International University. My thesis topic is vehicle detection using a deep learning method. Abstract. The use of deep learning based object detection methods in computer vision is covered in this thesis. The primary objective is the vehicle detection and the identification of various types of vehicles found in Bangladesh. In the present, one of the key prerequisites for application like traffic monitoring and autonomous vehicles is vehicle detection. Bangladesh presents extra difficulties because of the unpredictable traffic, the wide variety of vehicles, and the dearth of robust dataset. On the vehicle detection system dataset, various neural networks were trained utilizing YOLO V5, YOLO V6, and YOLO V7 for the detection. The model was trained using YOLO Google Collaboratory and a cloud-based platform using YOLO V5, V6, and YOLO V7, written with Python 3.10.4 the codes. The dataset for training was organized using RoboFlow, an online-based computer vision technology. Using a smartphone camera, data was collected. The model with the most effective performance and the most promising result was Yellow B7. Yellow B7 has an extremely remarkable recall rate and precision, which is sufficient to find vehicle. In comparison to the other two models, it was also able to detect vehicles with greater accuracy. This study has a lot of potential and can be seen as a development for autonomous vehicles and smart traffic system in Bangladesh. Background: as the population and the transportation network both grow daily, so does the need for management of both. As a result, the number of machinery of all kinds, including automobiles, increased concurrently. In light of this, it is necessary to manage new subjects like traffic accident and numerous other problems. New trends and technologies have been discovered and created to handle each and every milestone that humankind is aiming to attain, because managing them using the outdated approaches is difficult. Highway and city traffic is one of these difficulties. To deal with this phenomenon, numerous options such as traffic lights, signs, etc. have been implemented. These choices alone seem to be insufficient or ineffective. A decision-making process can use data produced by automated camera surveillance to generate new technologies like object detection. With the ability to recognize and classify vehicles, we can enhance how traffic moves along roadways, prevent accidents, and keep track of traffic infraction and crimes. This is the table standard classification of vehicles and classes: bike that is in bike class, bus that is in bus class, car is in car class, ambulance police car, this is in emergency vehicle, truck pickup tanker this is in heavy transport, laguna that is in public transport, rickshaw is in rickshaw class, CNG auto rickshaw that is in CNG class. Motivation: analyze the previous vehicle detection techniques deeply, determine why the techniques fail to detect vehicles. Also helpful for autonomous driving vehicles for detecting vehicles. Provide some favorable suggestion to reduce error in vehicle detection. Hopefully this research would be helpful for detecting any vehicle more accurately and perfectly. Scope: help the Bangladeshi Traffic Authority to find any vehicle more accurately, help the security management for traffic surveillance in any area, help the autonomous driving system to work correctly, reduce the errors in detecting vehicles. The study's objective is to develop a low-cost system that will enable our country to achieve the best result possible in accordance. Literature review. From this paper, we can see the authors aim to develop a system that gives us a good balance between accuracy and time taken for detecting objects. The author used CNN, RCNN, fast RCNN, and faster RCNN. The lack is low accuracy in overall method. The next paper here authors aim to develop a system that gives more accurate detection on vehicles. Lack is accuracy is very low, and the method is faster RCNN. The next paper, the finding is the system will work only if the camera is installed on the right place. Installation of cameras may also be termed as challenging, as the entire system depends upon the placement of the camera or radars or whatever device that are being used for the model. Method: here really hard like feature Adabost and Adabost algorithm artificial neural network. And the lack is the model need a very good qualityful camera and proper placement with which is quite very precious. Also, if camera placement is wrong, then it won't detect correct vehicle. The next paper is finding is yellow algorithm is able to detect the vehicle continuously and precisely. The method here is used in RCNN, fast RCNN, faster RCNN, and YOLO. The lacking is this model can detect small vehicle in image. This model's finding is SVM works perfect while dealing with unknown data. Method SVM decision tree. The here is key finding is YOLO method has an better yielding than the SSD methods for all the cases described in this work. The lacking is low accuracy in overall method, and the method is SSD and YOLO. Data collection capture different images through smartphone camera inside of Dhaka and outside of Dhaka. Proposed model I applied these three models such as YOLO V5, YOLO V6, and YOLO V7. Raw data captured image through smartphone camera. Here is my raw image sample. Data processing. I resize the captured or collected image to 64 into 64 pixel size. After that, I use different blurring techniques for removing grain from images. Then I use row side for annotation and label my data. Methodology YOLO V5. In YOLO V5, we can see the overall accuracy is 76.6, that means 77%, and the overall recall is 55%. Here is the precision recall curve, here is the recall confidence curve, and here is the F1 confidence curve. This is the confusion matrix of my model. That is YOLO V5. The output of YOLO V5. The output of YOLO V5 is quite impressive. Here it can detect various vehicle, but that is not good enough. YOLO V6. Here we can see the accuracy rate of YOLO V6 is 24%. This is the precision recall of YOLO V6, and this is the output of YOLO V6. In output of YOLO V6, we can see the YOLO V6 model can detect the vehicle correctly. Here it is detecting cars, but the bus or other vehicle are not detected. YOLO V7. In YOLO V7, here the precision recall of YOLO V7. The YOLO V7 overall accuracy rate is 83, that means 84%, and the recall rate is 42. And the output of YOLO V7 is here it is detecting all types of vehicles that is in our selected classes. Here is the CNG, here is the bus, car, and others vehicles. Comparison and result. From this above model, we can see the accuracy rate, recall, and the map mean average precision values of YOLO V7 are much higher than YOLO V5 and YOLO V6 model. The accuracy rate of YOLO V7 is 84%, for YOLO V5 77%, and YOLO V6 that is 4%. So YOLO V7 model can detect vehicles more accurately and more correctly. So we can see this is the suitable model for detecting vehicle accurately and correctly. Conclusion and future work. The study clearly shows that YOLO V7 object detection was successful in accurately classifying and localizing the all item kinds, and that it is well suited for real-time processing. The proposed end-to-end architecture has all the components needed for deployment and orientation for monetizing, and it was successfully developed. The S point of the vehicles can be determined using a variety of techniques because there are entirely open source. The libraries and software used in our project are very adaptable. The fundamental issue that plagued traffic management was its lack of effectiveness. We can infer from this that it adopted by if adopted by any traffic management body, it would make their work easier and more effective. It could be further improved in the future to be used more effectively in real-time traffic analysis. It can be utilized by improving the algorithm and using larger and more diverse datasets. By connecting it to other sensor, its incorrect detection can be further reduced. Thank you.